Chemistry isn't just another difficult subject. For many bright students, especially students with ADHD, chemistry is the first class where their old way of succeeding stops working. Before chemistry, they may have been able to listen in class, remember most of what the teacher said, and then just study the night before and still earn good grades. That may have worked in middle school science. It may even have worked in biology, where a lot of the early material can be learned through vocabulary, diagrams, and recognizing patterns. Then they reach chemistry. Chemistry is almost like learning a new language and doing algebra in that language at the same time. The student reads the problem in ordinary words. Then they have to translate those words into chemical symbols. Then they have to decide which mathematical relationship applies. Then they have to carry out several steps without losing units, charges, signs, or significant figures. And finally, they have to decide whether the answer actually makes any chemical sense. That's a very different demand on a brain. Even individual letters can mean different things depending on where they're written and how they appear. An uppercase K usually refers to an equilibrium constant. It might be KC, KP, KA, KB, or KSP, depending on the type of equilibrium. But a lowercase k often represents a reaction rate constant in kinetics. To someone who already knows chemistry, uppercase K and lowercase k look obviously different. To a student trying to hold an entire multi-step problem in working memory, that tiny change can be easy to miss. The same kind of thing happens everywhere in chemistry. A number in front of a formula means something different from a number written below it. A subscript may represent a charge. A symbol may mean an element in one place and a quantity in another. The student has to notice all of these details before they even begin to solve the problem. So when a capable student suddenly struggles in chemistry, it doesn't necessarily mean the material is beyond them. And it doesn't necessarily mean they aren't studying enough. Sometimes the way they're studying no longer matches what the subject requires. Reading the chapter may make the page feel familiar, but it doesn't teach the student how to translate an unfamiliar problem. Watching someone else solve 10 examples may make sense while they're watching, but it doesn't prove that they can choose the first step alone. Chemistry requires a repeatable thinking process. The student needs a way to ask, what is this problem asking me to find? What information do I have I been given? What do the symbols and units mean? Which relationship connects what I know to what I need? What is the first step, and how can I check whether my answer makes sense? That process becomes especially important for students with ADHD. A dense chemistry problem can overload working memory before the student has even chosen where to begin. They may understand every individual part, but lose track of how those pieces fit together. Then they freeze. From the outside, it can look like they didn't even study. Inside, they may be thinking, I know I learned this. I just can't figure out what the question wants me to do. That's why simply telling them to study longer may not help. More time spent using the wrong method can create frustration without creating independence. The goal is not merely to put more chemistry into their head. The goal is to give them a repeatable way to turn words into symbols, symbols into math, and math into meaning. Once they have that process, chemistry becomes much less mysterious. They may still have to work hard, but now the work has a direction. In the next lesson, we'll look at the difference between understanding chemistry when someone explains it and being able to solve it independently.